Alright, year 11, exercise books out, phones away. Phones away, boys. Let's go. We're going to start exercise 17B. Shh. Listening. Shh. So, last session I taught you first principles. I talked about what calculus was. And at the end of it, what I hope that you remember was it was just the gradient. The gradient of a straight line. If you keep that in mind, then it doesn't matter how many rules I teach you from here, you're just finding the gradient of a straight line. I'm going to keep repeating that because I say that to my year 12s all the time. They still forget. It is the gradient of a straight line, but a tangent line specifically. Okay? So, here we go. I want to show you how to use the power rule first. Okay, how to find the gradient first, and then I'll show you some examples where you're using the gradient to solve the problem. So if you just remember, it's just the gradient. It's just the gradient. Okay? Here we go. Exercise 17B, power rule. Before I show you the power rule, here we go. Just remember, purpose of first principles, which what I showed you last session, was really just to find the gradient. Okay, but it's not any type of gradient. It's a gradient at one point, because that's what tangent means. Tangent is a straight line that touches the curve. It doesn't matter what curve it is, it touches the curve at one point. Okay? Because it touches at one point, we want to know when it touches that point, what is the gradient? Means that the slopeness, how steep is that line when it touches that curve? Okay, so you can have any kind of curve. I can make up one right now. Okay, I could say this. I could say you can have this curve. Okay? Kind of looks like a sine curve. But this is made of infinitely many points. And you can choose any point on the curve you want. Let's say this point over here. Then when you draw a tangent line, which is a line that touches that point once, that's a tangent line. Okay? When it makes a tangent line, there's obviously a steepness. That's what we're trying to find. We want to know this straight line y equals mx plus c. We want to know what m is. That's the point of first principles. The problem is that from what we understand, to find gradients back in year 9, you need 2 points. This only has 1 point. That's a problem. Okay, so we've only ever done gradients with 2 points. So how do you find the gradient with only 1 point? This is where first principles came in. They said, well, make up an arbitrary second point. Okay, make an arbitrary second point on the curve. And then what if you made that point closer and closer and closer to the original point? So what if you did pick 2 points, but they're so tightly close to each other, so when you did find the gradient between the two, it's technically the same as the gradient at 1 point. Okay, that's the theory. So, what I showed you last session was to find the gradient, we're going back to year 9 again. Gradient is y2 minus y1 over x2 minus x1, and that's technically, using 2 points, that's how you would have done it back in year 9. Okay? Then in year 11, how do you find it for 1 point? I showed you, the name for it is called the first principles, but really it's the same thing as finding the gradient using 1 point. So it's what you did in year 9. I'm doing exactly the same thing. This is now x plus, what if I pick that second coordinate, just a few h amount away from the original x? Okay, so if x was at 1, then what if h was like 0.0001? Okay, so that's why I'm just picking x and x plus h, just bar amount. Okay, the limit of h approach 0 just means what if I made that h very small? Okay, so it is different from x, but what if it's very small, just a very small addition to it? Okay, so that's y2 minus y1, x2 minus x1, you find that it tends to cancel out. Okay, so that was the first principles that we used, and in the first exercise, all you learnt was how to find the gradient doing that. And it was pretty easy. You just found x plus h, sub it in, sub x in, and then simplify the problem. That was the hardest part of the algebra, simplify it down, and that's all you did for 17A. Okay? Now, 17B, we don't want to do this all the time. Okay? This takes too long to do. There has to be a quicker way, and there are many multiple ways for different functions. So the first rule that you're going to learn, instead of doing the first principles get your answer, we're going to use power rule only for power functions. Okay, that's why it's called power rule. So what's a power function? Power function is anything with power. So x to the power of 2, x to the power of 3, x to the power of negative 1, x to the power of half. You can use this power rule. Okay, so instead of doing it like this, instead of doing this to find m, they've already figured out the rule using this principle. They figured out a rule to do power rules. Normally I show the proof to it, but for sake of our lessons and trying to catch up, I'm just showing you the rules. You're going to learn the rules, you're going to memorize the rules, and you're going to be able to apply. But don't forget what was the purpose. Okay, don't forget the purpose. The purpose is very simple. It is to find the gradient of a tangent line. That's how simple it is. Okay? Okay, here we go. So, some notations for you to copy down. You will see that sometimes if they call the function or the equation that you have or the curve that you have, instead of saying y equals x squared, sometimes they'll say f of x equals x squared. So then how do you say the gradient, or we say f dash of x? So that prime there, it's not a negative one, it's a dash. It's like a complement, yeah? But f dash of x is another way of saying that to find the gradient. Same thing with this one. Instead of y, we say dy dx. Now, if you're wondering what the d stands for, it's delta. Delta y, delta x. If you don't know what delta means, it means change. Okay, so it's kind of like what this is doing. You're going from y1 to y2, the change in y over the change in x. That's what they're trying to say. So delta y, delta x. Okay? Now, in terms of language, how do you know when you have a calculus problem, or how do you know when you have a sort of a find the gradient problem? These are the common terms they use. They will say derivative. They will say differentiate. They will say gradient. They will say average rate of change, and they will say tangent. All of those words there tells you that you're just finding the gradient of a tangent line. That's it. Okay? And you'll find that even circular functions, tan, theta, that actually is the gradient as well. Okay, which is the derivative, but that's later down for year 12. Okay. What I'm trying to say is the change of your vertical values over the change in your x values, which is horizontal, that is the gradient. Okay, so y values, x values. That's why opposite over adjacent is also the gradient. Okay, so tan theta is opposite over adjacent. That's why tan of an angle is also the gradient as well. But that's for next year. Okay, for this year, you're not using that. But just keep in mind, everything you're doing all here is just to find m. Okay, that's all it is. If you keep that in mind, everything else is easy. Everything else is going back to straight lines, find y-intercept, sub in an x and y coordinate to solve the problem. That's how easy it is. So the hardest part of year 11 right now, what are you doing? Finding m. Okay, so don't forget that. I'm going to keep repeating that. Finding m. Finding m, this is the gradient. Okay, so here we go. What's the power rule? This is your power rule. So to summarize it, they say, all right, if you have x to the power of n, we don't know what n is. Okay, so it could be x to the power 2, x to the power 3, x to the power of half, x to the power of negative half. Doesn't matter. A is the value multiplied to it, or the coefficient. Okay, so remember ax squared, then a is the number in front of it. If this is your function, then we call that a power function. Then you can use this rule, instead of doing the first principles, which going through all this process to get the final answer, where you make h approach 0, this is the shortcut. Okay, so they've done all the proof for it. There's a proof where it all cancels out, and it ends up being this. Okay, so the answer is n, which is whatever the power is, times with whatever the original a was, times with x to the power of n minus 1. Okay, so what's an example? Last lesson, if you copied the notes, you can look back at your notes as well. I gave you a quadratic curve. When I introduced the first principles, I gave you a quadratic curve. And then when we went through all the first principles, we simplified it down, and then we got h to approach 0. And what you actually got as your answer was 2x. Okay, so if you look at your notes, it was 2x. Now, if we use this rule, you can skip all those steps and you get 2x as well. So I'll show you. So how do you use this rule? If f of x equals to x squared, using the rule, n is the power. So what's n equal to right now? 2. What's a equal to? What's the coefficient? 1. So using the rule, f dash of x has to equal to 2, which is n, multiplied to a, which is 1, multiplied to x to the power of 2 minus 1. So let's simplify that down. That becomes 2 times x to the power of 1, which is exactly the same as what you got from last lesson. This is a quicker way, but it only works for power functions. Okay? First principles work for every function, but this one only works for power functions. Okay? So you can't do this for sine. You can't do it for a sine problem. So there's a rule for sine. You can't do it for a cos. So there's a rule for cos, and you're going to learn all that. So that's what I meant by there's a lot of rules, and you just memorize all that, and you just apply. Okay? So I'm showing you the first rule. It's a power rule, and pretty much all of year 12 students will know how to do this first step because it's the easiest one. Drop the power, minus the power by 1, and that's how you do it. Most students will be able to do this, okay, unless you make a mistake with fractions and whatnot, but usually, that power rule is fine. The issue is chain rule, and I'm going to spend about, hopefully this entire week, the end of the entire week, we're going to try to focus on chain rule to make sure you know how to do chain rule. Okay? But here we go, power rule. So I've just done the first one, exactly what we've got for first principles. Let's do a few more. Okay, so when you're finding the derivative, or the gradient, or differentiate, or finding the average rate of change, or find the gradient of the tangent line, all of which means the same thing, you can do it not just on the first term, you can do it on all terms. Okay, so what does that mean? That means you can differentiate x to the power 5, you can find the gradient of negative 2x cubed, and you can find the derivative of 2 all individually. Okay, so like before, you know how I gave you y equals x squared, and you know the derivative was 2x? Well, you can do the same individually. Okay, you can do them all individually. So treat them all individually. If you had y equals x to the power 5 using your rule again, what would the derivative, which is dy dx, or the gradient, remember this means gradient, what would the gradient be using the rule? X to the power 5 becomes what? What would it become using the rule? You had the rule just now. Should I go back? That was the rule. Ax to the power of n, drop down the n, times the coefficient, times x to the power of n minus 1. So let's go back, x to the power 5. The derivative is 5x. Okay, sure. Minus? Not 6? No. 1. So the rule, so let's look at the rule, it was n minus 1. Okay, so you always subtract the power by 1. So let's have a look. The power was 5. So really you're doing power is 5, take away 1. Drop down the power, which is the 5 here. So 5 times that gives you now 5x to the power of 4. That's the derivative for the first term. Let's look at the second term. Second term, if I gave you y equals to negative 2x cubed, do the same rule. dy dx will give you what? Whoops. What do we give you? Very good. Drop down the power. So I'm going to do it in blue so you can see. Drop down the power. So I'm going to do it. Drop down the power. 3 times coefficient, which is negative 2, times x to the power of n minus 1. So 3 minus 1. Same drill. Same drill all the way. So this gives you now negative 6x squared. Okay, so you can see I'm just differentiating each term. Okay, so this whole equation, I've differentiated x5, x to the power 5, drop down to 5, take away 5 by 1. So it becomes 5x4. Next one, I did the same thing. I said, what if I had to differentiate this? Drop down to 3, so it becomes 3 times negative 2, x to the power of 3 minus 1. Same thing, minus the power by 1, negative 6x squared. Now, the last term, 2. What is the derivative of 2? What if I gave you y equals 2? There is no x. This is a problem. But if I were to put an x, what should it be? X to the power of what? 1. Oh, no, not 1. 0. Because, now for those who wondering how do you do the last term, you can write it as 2 times 1. But another way of writing 1 is you can write 2 times x to the power of 0. Because 2 times x to the power of 0 is the same thing as 2. Now you can use a rule. Let's do the rule, dy dx. What would that be? You got the coefficient as 2. Okay, so very similar drill. The power, I've just changed 2 to 2 times 1. I've changed 1 to x to the power of 0. So I can use the rule. So the rule says if it's x to the power of 0, the power is 0. Drop down the power. Yeah. Okay. 0 times 2 times x to the power of 0 minus 1. Okay. It would just be 0 because you're multiplying everything by 0. Okay, so I'll write down the intermediate steps so you can see. This will be 0 times 2 times x to the power of 0 minus 1, which is 0. Now, what I want you to think about, remember I said, don't forget the purpose of the whole idea of differentiating, okay? You're trying to find the gradient. Now, if I actually asked you to sketch y equals 2, okay, if we sketch y equals 2, I want you to see, what does y equals 2 look like again? How do you sketch y equals 2? Yeah, horizontal line at 2. Now, if I asked you, what's the derivative, which means the gradient? What's the gradient of that line? 0. That's why it makes sense that when you find the gradient or the derivative of 2, it's 0. The derivative of any number, if you have any number like 1, 2, 3, 4, a derivative of any constant has to be 0 because you're really just saying what's the gradient of that line. That's essentially what you're saying. Okay? So, it's going back here. So my final answer, so if I write it all out, my answer has to be the derivative of y equals x to the power 5 minus 2x cubed plus 2 dy dx is equal to 5x to the power 4 minus 6x squared plus 0. That is the answer for the derivative. Okay, so another way of seeing that, derivative means find the gradient, that means use first principles. Okay? So it says in differentiate with respect to x. What does that mean? Differentiate means to find the gradient. Respect to x just means make sure you focus on the x's. Okay, because later on you get different letters. So when you say with respect to x, you know that you're differentiating from x to the power of, not z to the power of, not y to the power of, but it is x to the power of. Okay? That's why it says with respect to x. Let's do another one. So all I'm doing right now is I'm using the power rule. Okay, I'm just using the power rule. Let's try another one. Let's try this one. Same drill. Find the derivative. Look at that. It says find the derivative means find the gradient. Find the gradient. Now you got 3x cubed, you got minus 6x squared, you got plus 1. Let's differentiate each one individually. What's the derivative of 3x to the power 3? Matt, what would it be? Yep. Good. Times to the x. Good. Very good. So that simplifies it down to 9x squared. Good. So I differentiated the first term. Do the second one. What's the derivative of negative 6x squared? Let's go with Hamish. Negative 6x squared. I want you to differentiate that term. Okay, the power rule again. It's not a, remember, ax to the power of n. Yeah? Now, if I just compare the two equations, Hamish, have a look. You got negative 6, you got x to the power of 2. What is my a, what's my n? That's all you need, man. A and an n. Thank you. So what was the rule? I got you guys to copy down the rule. So copy down the rule. Very straightforward. F dash of x, which is the derivative. It was n times a times x to the power of n minus 1. Nothing hard. Same drill. Over and over. So that's your a. That's negative 6. N, which is your 2. Put in a 2. 2 times negative 6 to the power of 2 minus 1. Okay? Follow the rule. Just follow the rule. I'm not teaching anything hard. You're just applying and applying. It's like finding the area of a triangle. If you can do that, you can find the derivative. It's not hard. Okay? Just don't forget the purpose. So here we go. If you subbed it in, n is 2, a is negative 6, x to the power of 2 take away 1. That's negative 12 x. Okay? So your next part is negative 12x. Last part. What's the derivative of 1? What's the derivative of 1, Oscar? 0. That's what I said before. I said that the gradient of any straight line that's horizontal is 0. So that's plus 0. So your answer is 9x squared minus 12x. Okay? Now, just keep in mind, just in case you forgot how to do it, derivative of y equals 1, another way of writing it is 1 times x to the power 0. Because x to the power 0 is 1. 1 times 1 is 1. Okay? So if you use the rule, dy dx equals 0 times 1 times x to the power 0 minus 1, you can see that's why it's 0. Okay? Okay, now we haven't finished the question. The question said find the derivative and thus find f dash of 1. Anyone know what that means?
Substitute in find for x.
Yeah. It means find the gradient, because f dash means the gradient. Find the gradient if x equals 1. Now you've already found the gradient. Remember, f dash of x is the gradient. So find the gradient when x equals 1. So here we go. 9 times 1 squared minus 12 times 1. That becomes 9 minus 12 equals to negative 3. So what does that imply? So this is what I want you to think about. Don't forget what the purpose was. You found the derivative, which we did. Okay? But it says find the derivative when x equals 1. What's this negative 3 mean? So a lot of students in year 12, they can do all this step here, but they don't know what it means. That's when you have troubles solving. What does this mean? What's negative 3 tell me? Not the y coordinate? What are we trying to find? Remember the gradient. Remember this whole step. That means the gradient. That means the gradient. So if I sub 1 in, it just means when x equals 1, the gradient at that point is negative 3. So if you're having troubles understanding this, I'll draw a picture so you can see. Okay? This is essentially what they're saying. They're saying you have a cubic graph. So this graph here, let's say it looks like that. Okay? They're just saying when x equals 1, so when x equals 1, at this point, if I had to draw a tangent line, I've just figured out the gradient. That's what you just did. You differentiated to find the gradient when x equals 1. So at that point, what is the gradient? That's what you did here. You did gradient will equal to this. But where? There's so many gradients. You've got a gradient here, gradient there, gradient here, gradient there. There are infinitely many points. You never told it where. Then finally they told you, they said, well, at x equals 1. So at x equals 1, I want to know at that point, if I had to draw a tangent line, the gradient, what would that be? That's what you did here. You sub 1 into the gradient formula, and you found out negative 3. It tells you the gradient at that point. So now you know the gradient of this line is negative 3. Okay? How do you find the y value though? Because this is a typical year 12 question. They'll get you to find the equation in a straight line. You found the gradient. How do you find the y when you know x equals 1? So how would you find y? Yeah. All you have to do, if x equals 1, this tells you y. This is y equals to whatever x is. So if you know x equals 1, sub it in. And then you get the y value at this point. Then you get the coordinates. This is to tell you the gradient. This will tell you the y coordinate. So y coordinate, gradient. Y coordinate, gradient. They're two totally different things. F dash is the gradient. F of x is the y value. Okay? So in the later problems you'll find where the other classes are up to, all they're doing on top of what you guys are doing is finding out the equation of the line, which is only one more step, nothing extra. But if you understand the theory, we're just finding the gradient of a straight line. Okay, so if I had to draw this again, if I had to emphasize what you just did here, is you just found the equation of this straight line, which is the tangent line, y equals mx plus c, you just found the gradient. It's negative 3. You know the x coordinate is 1. So how do you find the y coordinate? Well, when x equals 1, sub it in. This is your y value. If you sub 1 in, you get 3 minus 6 plus 1. And what's that? Negative 3 plus 1 is negative 2. So you don't, oh, that doesn't make sense. Oh, because I drew the graph. I made up the graph. That's why. Yeah. Okay, so we now know the coordinates is when x is 1, y is negative 2. You know the gradient is negative 3. So if I actually went back to year 9 with you, remember back in year 9, if I actually gave you this equation, and I'll show you here, you can all solve what the others are doing right now. Tangents, very easy to do. You're just trying to find the equation of a straight line. So here we go. What's the equation of a straight line? Is what you learned back in year 9. I'll show you. It was y equals to mx plus c. You know m, you found m over here. That was negative 3. So you got y equals negative 3x plus c. How do you find c? Well, you know a coordinate. You figured out at 1, y is negative 2. Sub it in. That's what you did in year 9. Sub in 1 and sub in negative 2 times 1 plus c, and that gives you negative 3 minus 2. So C has to equal to 1. So if I actually asked you what is the equation of that tangent line, you would have said it is negative 3x plus 1. This is what the others are doing right now. That's what they're doing. But you see, I'm not interested in teaching you this whole thing. It's all about understanding what you're doing. Because if you understand what you're doing, it all makes sense. It's just year 9 maths. You're given the gradient, you've got a coordinate, sub xn, sub yn, solve for C. That was year 9. I guess what was year 11? The only year 11 part was understanding what this meant. See, year 11 we knew found the derivative means find the gradient. M can have any gradient at any point, so we didn't know where. Now I told you when x equals 1, find the gradient at that point. So you sub 1 into the gradient formula, f dash. We found the gradient is negative 3, so you tick this off. You're like, all right, cool, that's negative 3. You want to find C. Well, since you know at x equals 1, there's a point on the curve. Find the y value. You don't know what the y value is, so sub 1 back in here, and it tells you what the y value is. And that's what we did. We said when x is 1, y is negative 2. That's how I got my coordinate. After that's year 9 maths. So before you get to that step, it's understanding this. See, I'd rather spend more time for you to understand this theory here, because once you understand that, all that chapter 18, whatever the others are up to, tangents, normals, they don't need to know, because you did that. You're just finding perpendicular lines, parallel lines, straight line. You just did this at the very start of the year, straight line equation. That's essentially what you did at the start of the year. So you don't need to learn this. What do you need to learn? This. This is what you have to understand. That when you find the derivative, it's just the gradient. So you're just finding m. But you don't know the gradient of what? Which tangent line are we talking about? Because there are infinitely many points. That's why they told you it was at x equals 1. So at x equals 1 on that curve, I want to find that line, that specific line. So that's why I sub 1 into the gradient formula we figured out. We got the gradient as negative 3. Great, I got the gradient. But to find C, I needed a coordinate. But they gave me one coordinate. It told me what the x coordinate is. So the only way to find the y coordinate is go back to my y equation. Y equals to that is. So I sub 1 back in, and I get my x and y coordinates. When x equals 1, y equals negative 2, bam. See, so this step here was year 11. This step here is just substitution. See, if I never taught you gradients, and I said x equals 1, and I said, how do you find y? You guys would have been able to answer that. So that step that I'm doing up here is not a year 11 step. What was the year 11 step? Right there. And that's what calculus is all about. If you really, really take it all and condense it down, it's just the one theory. It's the gradient of a tangent line. That's how easy it is. Okay? But it's 2/3 of your course next year. 2/3 of your understanding is just a straight line. That's where it gets tricky and you do all these other things, but it's the same theory. Okay? Let's do another one. Here we go. Let's try this one. Actually, that's the one we just did. Okay, let's go to, let's try this one. So let's tie in the understanding we have, okay? Here we go. For each of the following curves, so you got different curves here. You got x cubed, you got a quadratic, and you got another cube, right? So you got these curves. It doesn't matter what curve it is, I don't really care. I just need to know, I've got a curve, and they want you to find the coordinates of the points on the curve at which the gradient of the tangent line at that point has been the given value. And now I know it's a whole mouthful, but all they just said to you is you've got a curve, and somewhere on that line you have a gradient of 8. I want you to find that coordinate where you get a gradient of 8. That's all they're saying. Okay, so if you really think about it, I'll draw a random cubic graph. Let's say this is a cubic graph. They're just saying somewhere, which we don't know where, we just know somewhere there's a point, and if you draw a tangent line to it, this tangent line has a gradient of 8. That's essentially what they're just telling you. They just said you've got a cubic graph, that's my cubic graph. They just said, find the coordinates, which I don't know what that coordinate is. I have no idea what x is, and I don't know what y is. But I do know at that point, they had to draw a tangent line, the gradient is 8. That's essentially what they're telling you. See, if I draw it like that, it's very easy to solve because you're like, well, how do you find gradient again? What do you have to do? It's only one skill. What do you have to do again? Rise over run, or in the year 11, this whole chapter 17, what have we been doing? Derivative. So derivative of this, but it just so happens that this curve is a power function. So you use power rule to find the derivative. But if it was a different curve, it was a sine curve, then you find the derivative of a sine curve, which I'll give you the rules for that too. And then if you have an exponential curve, then you use the derivative rule for an exponential curve. But you just have to define the derivative. You just have to find the gradient by doing the derivative. Okay, so let's do it. To find 8, I'm going to do another color. To find 8, we know we need to find m, which is the derivative. Okay, how do you find the derivative if it's x, f dash of x or dy dx? But what's our y? Y was equal to x cubed. So what is dy dx? Using the power rule, because that's a power function. So using a power rule, what's the derivative of x cubed? What is that equal to, Anne? Very good, and that simplifies down to? Very good, 3x squared. Okay, so all I did was just the power rule, drop down the power, so 3 times the coefficient, which is 1, times x to the power of n minus 1. That's all I did. 3x squared. Now don't forget, what does this represent again? What does this represent? Gradient. Gradient. Well, we know what the gradient is. They told us the gradient was 8. They told us the gradient is 8. So this 3x squared has to equal to 8. Okay, let's solve for x. So here we go. If I sub it in, I know the gradient equals to 8. Now you've got an equation. You've got 8 equals to 3x squared. Let's solve for it. 8 equals 3x squared. Divide both sides by 3. 8 over 3 equals x squared. And now let's differentiate it. I mean, square root it. So that gives you... There we go. Now don't forget when you square root, remember you get a plus and a minus answer. Okay? Now why does this make sense? Think about it. This can't be the only spot that has a gradient of 8. You can have it over here too. Somewhere there could be parallel lines. So somewhere over here in the negative region, it has to have a positive gradient 8 and a gradient of 8. Yeah, because it goes like this, and it gets flat, and it gets back to steep again. So at some point, they both have to have same gradients. Okay, so that's why this answer here is not just root 8 on 3, it's root of 8 on 3 plus or minus. Okay, so you have 2 coordinates. Whoops. Now, that was the hardest part. That was the hardest part that you had to do. Okay, the understanding that the derivative of this will give you the gradient. But they told you the gradient's 8, you just sub 8 in and solve for x. But now remember the question was to find coordinates. So now I know this coordinate, I've got root 8 on 3. How do I find the y value? What do? Sub it back into which one?
Y equals x.
Very good. That's as simple as it is. This is your y value. So you sub that x value back in here to find the y value, the y coordinate, and then you got your coordinates. So in year 12, that's essentially all you're doing. So what do? We were finding the gradient, or we find the equation of the line, or we find the coordinates. And I promise you, these are the only 3 things they're going to keep doing all the way through next year. 2/3 of your course next year is on that idea. Okay? That's how simple it is. So if you just remember it's just a tangent line and you're playing around with straight line equations, that's essentially all you're doing. Okay? The only difficult part is making sure your algebra is okay. Can you do fractions? Can you do surds? Can you factorize? Those are the basic skills. But in terms of theory, it's easy. An easy theory. Okay? Let's try another one. I'll do another one. Let's try.
Would we leave that as plus minus?
No, because you have to find the coordinates. So you got 8, when x equals to root 8 on 3, you're going to find the y value for that. And then when x equals to negative root 8 on 3, you have to find the y value for that. And that gives you the 2 coordinates. Okay?
So we'd actually find out what negative root 8 over 3.
Yeah, you would have to sub that into that. So technically, it would just be...
8 over 3 to the power 3.
Yeah. It would be root of 8 on 3 to the power 3, and this would be negative root of 8 on 3 to the power of 3. Essentially. Yeah. Okay. Let's do... let's try the last one. I mean B. Let's do B. Same thing. I've got y equals to x squared minus 4x plus 2. So let's draw the problem. You got a quadratic problem. And I don't know where I'm just going to draw a random quadratic. Okay? Now, what is our problem? They are asking you to find the coordinates when the gradient is 0. Now, looking at a quadratic graph, where would the gradient be 0? Gradient of a tangent line.
At the turning point.
Yeah, very good. At the turning point.
At the ball.
See, if I draw it to you, see at this point, gradient's negative. At this point, gradient's negative. At this point, the gradient's positive. The only time that you're going to have a 0 gradient is when it's horizontal. This is the bottom point where the gradient is horizontal. When the gradient's horizontal, it has a gradient of 0. Okay, so remember you have 4 types of gradients. Positive, negative, 0, and undefined. Okay? So, essentially what this question is asking is, find the coordinates of your turning point. That's essentially what it's asking. Okay? So I'm just drawing a random quadratic graph. I know that the gradient is 0 at the turning point. And how do you find the gradient again? What do you do? How do you find the gradient again? Here's my equation. Derivative.
Times A times X
Good.
power of n minus 1.
Very good. So dy dx has to equal 2. Now find the derivative of 2x. I mean x squared, which is 2x. Derivative of negative 4x.
1 negative 4 x.
Good. X to the power 0, because x1 minus 1 is 0. So then becomes negative 4. Okay? And then derivative of 2?
0.
0. Okay? And that's my answer there. Now, that's dy dx equals to 2x minus 4, but that doesn't tell me the gradient. Okay? I already know what the gradient is. What's the gradient equal to?
0.
0. So since I know the gradient is 0, 2x minus 4, yeah. X has to then equal to 2. Add 4 on both sides, divide both sides by 2. So what does that mean? It means that when x equals 2, that's when I have a gradient of 0. Now, if I know it's 2, how do I find the coordinates for y? What do I do? Yeah, sub it back into the original equation, and the original equation was this. That's how you find y. So I'm not finding the derivative, I'm finding y. So if x equals 2, sub 2 in. 2 squared is 4, minus 8 is negative 4, plus 2 is negative 2. So I know the answer, 2, negative 2. All right? How do we feel? Pretty good? Now, just before you all practice your questions, just a tip. The questions that are hard in year 11 that you get are these kind of problems. So you get used to how to do the root of x cubed, x to the power 4, 2x to the power 5, whatever all that is, you get used to it. The problem is when you get a function that doesn't look like that anymore. So what do you do in this case? All the problems you're going to get from here that you're going to find difficult, my suggestion is simplify it. Break it into its original terms. So you can see this one, for example, you can't differentiate x squared, 3x, and the 1 on the bottom. You can differentiate it if they're separate, because this is one whole fraction. They're not separate terms, it's one whole fraction. You have to separate it, then you would do the derivative. So y equals, if you separate it, it's x squared on x, plus 3x on x. Now those are two separate terms. But you can simplify them. X squared divided by x is x, plus 3. Now, find the derivative of that. See, that's easier. Okay, but what you can't do, which is what a lot of year 11s do at the end of year exam, is they will do derivative of x squared, derivative of 3x, and derivative of x. That's wrong. Okay, you can't do that. Okay, because that's one whole term. Remember the rule. You go back to the rule. What kind of rule did I give you? I only ever gave you y equals ax to the power of n. I never gave you x on x. I never gave that to you. I just said x to the power of something. Okay? So, if you want to differentiate it, it has to be individual. It has to be separated by a plus and a minus sign. Okay? So you can see x squared on x equals x. That one you can differentiate. 3 you can differentiate. Okay, so for all of these, you have to get them in separate terms. So this one, expand all the brackets. Okay, you can't do them in their brackets. It has to be separate terms. Okay, same thing with this one. You can't do derivative of x, derivative of 3. You have to split it out into its terms. Then you can do it. Okay? Later on, I'll teach you chain rule, and you can do a quicker way of doing this one. Okay? At the moment, you're just doing power rule, and that's all I need you to do. One rule, Don't forget the purpose. Okay? Here we go. Have a go with the first problem, 17B using power rule. As you move to the questions like question 6 and question 13, you'll be practicing the theory. Okay, so I'm just teaching you the first step is to learn how to differentiate using power rule. Okay? Later in the questions are about why you do it. So the more important that I want you to take out of the lessons are why you do it. Okay, because if you understand what you're doing, it makes a lot of sense. Straight line equations. Okay? If you don't get that, problem solving with calculus becomes a problem. Okay? And that's pretty much what next year's work is. Like if I literally just show you the exam that my year 12s just did, this is essentially the first question. Your first 4 marks out of 40, 10% of your marks is to do with derivatives. You see, you're going to learn the chain rule in the next few lessons, and you'll be able to do that. And that's 1 mark plus the next 3 marks. That's 4 marks. That's 10%. It's like that for every year. Since 2006 to 2017, the first question is a derivative question. Okay? So you're going over and over. All right, but you haven't learned these 2 rules yet. You haven't learned how to do chain rule. You haven't learned how to do quotient rule. Okay, but you're going to learn that. All right? But that's what I mean. Learn how to do it, then the purpose. Okay? Here you go. Have a go with that one. I'm just going to pause the video.